I'd like to invite Kasper from Hexens to speak about the new very cool tool called Gilder. So, Kasper.
All right. Yeah, thank you all so much for joining. I'm going to be talking about Glider. You may have heard of it. It's a new tool. And more specifically, we're going to be talking about how I use Glider to find vulnerabilities. And we do this by querying smart contracts for bug patterns. Before we dive into that, a little bit about me. So my name is Kasper. I've been the head of audits at Hexens for 1.5 years. Hexens is a cybersecurity firm, so we focus on blockchain technology. We do Web3 audits, ZK audits. We do Web2 pen tests, and much more. So as the head of audits, I mostly focus on the Web3 audits, so smart contracts. And during my work at Hexens, I've been able to do really cool audits for like Lido, Eigenlayer, Polygon, Layer 0, and 1inch. So besides this, I've always been in love with bug bounty. So I started my security journey through CTFs and bug bounty, first in Web 2, and then like 2.5 years ago, I started going into Web 3. Yeah, and I'm still doing some bug bounty. So right now on Immunify, for example, I'm like rank 34. Yeah. So today we're going to be talking about Glider. So you may ask yourself, like, what's Glider? It's basically a new query framework that's been developed by Hexens / Remedy, and we can use Glider to basically write queries, and you can write any kind of query across all smart contracts. So the query is run across all smart contracts on the blockchain, and using these queries you can write code patterns to look for in these contracts. So this could be anything, but as a security researcher, of course, I'm interested in finding vulnerabilities. So if you're an auditor, you've done like contests or bug bounty yourself, then you know that the same bug might appear in different protocols. This happens very often. And these are basically bug patterns that could occur in many places. So the magic of Glider is that we can take this bug pattern and write a query on it, and it allows us to basically abstract this pattern into a query and then run this across all smart contracts to find any instance of this bug in the blockchain. Besides vulnerabilities, you can of course use it for anything. So you can use it for analyzing smart contracts, for data science or compliance purposes. Right, you want to know like how many contracts inherit from this contract, or how many are using mixers and stuff like that. And besides that, you might be interested in like which smart contracts use this specific type of version. So a few months ago, you may recall that there was this a Viper bug where the reentrancy guard didn't work, and you could query all smart contracts that use this specific version and this reentrancy guard to find all instances of this. So I want to give this talk kind of not as from the perspective like an independent security researcher. So I've used Glider with bug patterns from my past, in like the past 1 or 2 years that I found on Immunify or in contests or audits myself. So and these bug patterns, I've used that to find critical vulnerabilities using Glider, and we're going to be talking about that. Yeah, so this is the UI of Glider. We're going to go over this quickly. So on the left, you basically have your queries, right? So you can create new ones, and then here we see the actual query. So we will go over some queries in detail, but I just want to show the full UI. It's a web-based interface, and the queries are run online in the cloud. And then once we run the query, we basically get our output. And the output could be anything. So in this case, I'm returning functions. So you can see that there's individual functions. We get their contract addresses and names. But you could return instructions or contracts themselves as well. In this case, this query that I've written executed returned me like 120 results. So the full database is like 660,000 contracts on mainnet that are in the Glider database, and this query will be run against all of them. And you can see that the 120 functions are returned. So these pass my filter and are returned to me. And yeah, you can see the execution time is 6 seconds. Yeah, so let's talk about one of the first basically successful disclosures. This was a governance bug in SafeDAO. So yeah, SafeDAO is a DAO. They have on-chain governance. So they have voting power, they have an on-chain governor contract for proposals. And yeah, that's basically a success story because there was this bug pattern in Delegation that I found many times on projects on Immunify. And this was basically one of the first things I wanted to try once I got like Glider mainnet access. I immediately created the query to find this bug. We will talk about the bug after this, but yeah, it was very successful. Like I just created the query and immediately got a couple of instances where the bug was found in like live protocols basically. And the whole story with SafeDAO was very smooth. So we contacted them, reported the bug bounty was paid, and a write-up is also published. So if you Google remedy or SafeDAO bug, yeah, with remedy, then you might find it on Google. And yeah. So this is basically the bug pattern that I was looking for. So we're gonna get a little bit technical now. Just want to go over like the bug patterns and how I created the queries that can find those kind of bug patterns, just to motivate you to try the same. So the bug pattern is basically, if you're familiar with on-chain governance, there's always this function which should return your voting power in the past. And this is usually called like get past votes or get prior votes. It's part of Open Zeppelin voting spec as well. So the bug is basically that there's this block number, right? And this function should only return your voting power in the past. But in this case, they have less than equal time. So because of the equal, it basically means that it also returns your voting power in the present. And this by itself does not necessarily give some impact, but it depends on how this is used. And if they, for example, have this voting process where the proposal or the voting can happen immediately at the creation. So basically you create a proposal and then that same block number is also your start block, your snapshot block. Then you can vote, you can move around your voting power and then vote again from another account because this returns your voting power in the present. So normally we'd recommend to use just a less than, so that only block numbers in the past can be given, and then no manipulation would be possible. Right, so this was the case with SafeDAO. So I've written a very simple query, so you could do this actually in a better way, but I want to start with a very simple query, just to kind of show you how Glider works. So basically we rewrite the query function, and this function will be executed by the query engine. So as you saw in the UI slides, like the query language is just Python, right? So there's this Python API that you can use with a lot of functions that help you write those filters. But because it's Python, you can still do basically anything you want. So you can write any kind of query, modify data, and return whatever you want. So in this case, there's basically two passes, right? So the first one really uses the Glider API. So the first call, functions, what this does is it groups all functions in the entire database, right? So all functions across mainnet will be in there, and then I filter that very simple with like a provided API function with one of the names. So these are the two variations that exist most of the time. So there's get past votes and get prior votes. And then I execute the first query. So the 10,000 is just a limit to kind of limit the execution to make it a bit faster. And then in the second pass, so basically the first pass gives me all functions in mainnet with these two names, with one of these two names. Okay, so now I want to know like which one of those uses require and the less than equal them. So in this case, I made it very simple. You can actually, it's better to do it in another way where it's a bit more exact. So this will give you a couple of false positives, but it should cover most cases. So very simple, we just do a different loop in Python this time over all of the functions, and then I very simply check whether those things that I'm looking for are in the source code. So string-based search is actually very fast, and this will, give you results in seconds. Okay, let's look at a bit more difficult examples. So this was another bug pattern in Delegation. So it's again governance, but this time in Delegation. So some protocols, they override this delegates function just so that people who have never delegated are basically their own delegate. And you can see this in the code, right? So the internal mapping with the account, if this is set through address 0, the account itself is returned. And only if it's not, then the actual delegate is returned. So if you have never set it, it should be set to 0, and you will be your own delegate. And that's fine. That might work, but there's this thing that you need to keep in mind, that the delegation function should never be able to be called on address 0. So you should never be able to delegate again to address 0, because this is kind of like a magic value which points to yourself. And yeah, to tell you why, like the delegate function works like a mint and burn function. So if the from address is an address, it would burn your voting power from there, and then the to address, it would mint it to there. So in the case where you delegate to address 0, the from address would be yourself. So you would be burning your voting power, and then it would never be minted because the to would be address 0. And then once that is over, your voting power is gone, but because of the magic value, you are still delegated to yourself. So if you would call this again, it would basically not work because you would get an on the flow revert, because it would try to get your voting power from yourself again. So yeah, to put this into a query, let's start again. So at the beginning, I do a full glider query. So I look for all functions, and I want to filter on signatures for that function that we just saw. So we execute that, and then in our res object, we have a list of all functions that have this signature. Then we want to do a second pass, so we loop over all of these functions, and I do the same source code trick again with address 0. So basically, if you saw here, there's address 0 in there. I just want to look for delegate functions that actually have that. So after the if, we have a function that does have that, and in that case, in the middle, you see that I try to go from function. I do get contract, which basically moves up again. So I have this function, and I move up to the contract. Then I call function, so it gives me all of the functions in the same contract. And then I want to filter that for all functions that call the underscore delegate function. So the underscore delegate function is the function that actually sets the delegate. And I want to know all the functions that call that one. So all of the, for example, external functions that call that internal function. Then I do the same trick again with source code. So if there's no address 0 check in there, we basically have our candidate potential bug. And then in the end, what I do is another pass, because I want to get a very specific function to return. So, and I do that just to kind of make the manual review easier. So that's something nice, very nice about Glider, is that it's still Python, right? So you write this query, and it leads you to interesting functions or contracts. And then in this case, I have this function, but I want to return another function because it makes reviewing it later easier. So you can see I look for the functions that call underscore delegate, and then if they don't have address 0, I want to return underscore delegates. So I can choose what to return, and that makes reviewing it later very easy. So yeah, I want to discuss a third kind of bug. So this one is more known, I think. It's a layer 0 reentrancy. So the bug is not actually in layer 0, it's in protocols that build on top of layer 0. So layer 0 has this, on the final line, you'll see endpoints, so send. So this is the layer 0 endpoints that you can use to send messages to other contracts across the layer 0 network, right? So you can send messages to different blockchains. And there's this parameter, the refund address, which will be refunded the native fee if there was too much. So if you send too much ETH to this function, then it would be refunded to this refund address. And protocols that build on top of layer 0, they often set this refund address to message sender, which makes sense because they're supposed to pay the fee to transfer tokens to another, or do a swap on another chain. And then if they have sent too much, it should just be returned to them, right? But the thing is that inside of this send, a call is made with this ETH to the refund address. So this gives potential for reentrancy because it gives execution to the message sender. In this case, it depends, right? So as is always the case with reentrancy, it really depends on whether there are storage rights or external calls after the external call to the attacker. So in that case, we need to look for calls to layer 0 send with storage rights afterwards. So that's what I do in this this query. So we won't go over this line by line, but I'll just go over it quickly. So basically in the beginning, instead of functions this time, I use instructions. So this is, you can also use contracts, variables. There are different basically things that you can query for. So in this case, I start with instructions. So this gives me, instruction is basically a line of code. So this gives me all line of codes across the entire mainnet. And I want to filter this down to instructions that are call instructions to this specific signature. So this is the layer 0 send signature, and then I execute that. So now I have all calls to this endpoint. In this case, I do a second pass because I want to look for only storage, things that have storage rights, right? So for this instruction, I use the Glider API next instructions to loop over these, to see if there's any storage right after this call. And yeah, as is the case with reentrancy, if this happens in an internal call, it might still be the case that there's a storage right after the actual call of the function, right? So the storage right might be immediately after this call, but it might also be after the call to this function. So there might be another internal function that uses this function. So I also need to check those. So that is what happens here. I basically loop over all of the functions. I try to get the functions that call this specific function, and I check those. I need to check those as well. So it bubbles up all the way to the external functions to check if there's any storage right afterwards. So this reentrancy query did help. It led to one finding in layer 0 domains. This is like a name service for layer 0. It's not affiliated with layer 0, but it is called layer 0 domains. They had a bug where there were some storage rights after the layer 0 sent, and this was exploitable. Right. So that's basically the three types of bug patterns that I wanted to discuss. So those three I found during my bug bounty or audits, and I basically turned them into queries and try to find the same thing across the whole mainnet. So I definitely want to motivate you to try to do the same. Glider is available at glide.r.xyz. It's on our Remedy, our bug bounty platform. You just need to create an account, and you'll be able to try Glider on testnet. Yeah, here's some of the people that like to use it. So, yeah, we also have a large community, so you'll be able to join the Discord or Telegram or Twitter where you can get help. So we are all in Discord, so if you need help turning your ideas or bug patterns into queries, you can just join the Discord. I'm in there as well. And just ping any of us if you need help. And yeah, we'd love to hear your success stories as well. So don't hesitate to get in contact. Also, I forgot to mention, in the Glider UI, you'll find on the left bottom, you'll find the Glider documentation. It's very thorough. You'll find basically everything you need. So all of the API calls that I used in my queries, you'll be able to find there with examples. So yeah, it should be pretty easy to get you started if you have some ideas that you want to look for. Yeah, that's it. Thank you very much.